This video was by request of the owner, who asked if I could possibly make a video of the overhaul, and I wasn't sure I could. I've been awfully busy, but in the end I decided to, and I'm glad I did, because there were some interesting aspects to this one. This is a late model 122 Mark III that, at least at some point, was in the hands of my friend Jefferson over at JPO Solar, and also at iHeartRadio, apparently. So let's get this thing apart and evaluated and see what we're in for. The first thing I want to do is just evaluate it. This is operational, and it has been in operation. So I'll just put it on the audio analyzer and test a few things and make a few notes. Even though video's being made, I still like to look back at notes and have documents of what I've done and when and how it turned out. Just kind of an overall view. It is extremely clean. Very little visible wear on anything. Even the case looks nice. Now let me get it set up and focused here, and I'll put in my homemade wound flutter tape. Speed tape really, but it works out at somewhere around 0.03%, sometimes a little bit better, and that way I don't wear out my factory tapes. Let's give it a try and see what we've got. Takes it a second. Okay, looking like around 15 or 0.15, 0.16. We'll see if we can't improve that. Pretty consistent there. Which is good. The consistent part is good. Let's see what kind of speed it's been running. So just a tiny bit slow, not bad. I'm going to stop this here in just a second, and I just want to listen to a couple of tapes. In fact, I just recorded a tape here a couple of days ago. I think I'll just put that in and listen to that, see how it sounds. Make some notes. And it didn't sound good at all. So I'm going back here and I want to check the azimuth. There were some anomalies in the playback that were just, and this explains it right here. The azimuth is way out, way out. Yeah, that explains the bad audio. So let me just move this up here to what most people are used to seeing. Zoom in on that a little bit. Okay, there's what it looks like, which is not good at all. So let me just see here if I can turn a screw and bring that back into spec or close to it. This is so far out, it's amazing. Now we're starting to get some amplitude. I'll turn that back down as drop. Okay, let's get it in phase. Move this around here a little bit. I know this isn't a good angle, but and I know people want to see a Lissajous pattern. Well, there's that, and that's the flutter. I prefer using my audio analyzer for this, but I do both. It all works out. I definitely prefer this. You can see that I can dial this in just a little bit finer. Kind of center it more easily. The other thing I want to check is the playback azimuth. A lot of times people will dial in someone else's tape on their deck, and I want to understand why this is out as bad as it is. And it's possible that he was just dialing it into someone else's tape that was out of alignment, recorded out of alignment also. That happens a lot. But if the record head is out, then that probably isn't what happened, because regardless of what you do to the repro azimuth on the repro head, the record head should remain in alignment to the repro head. So, and there's the record head, and this is also horribly out of alignment. So I'm not sure. I don't know why it's like this, but we're going to fix all of this. Here it is. You can't see me turning the screws, but I am. So this measures phase on 4 different frequencies. You can see it on the bottom right hand of the scope: 15.8 kilohertz, 11.8, 5.7, and 2.8. And this is now aligned to the playback head. This will all get redone, obviously, because it's all coming apart, but I'm just making notes and looking at what I've got. So let's see if it can record a normal frequency sweep. This is monitoring the recording. And I'll go back and play the recording, and this is the actual frequency response. So you can see it's falling off there quite a bit, maybe 4 dB at 10 kilohertz, at least on the right channel. Left channel is a little better. Okay, so that's got quite a bit of drop off. Not horrible, but I've still got decent response. Okay, so I'll just run a quick manual alignment off camera and see if I can get it up to more of a flat curve. And then that also tells me how good of shape things are in. And this is following the manual bias and level adjustment on the front panel. And you can see this is just fine. So I feel like my heads are probably in good condition. Here's the playback. Really important on these to test the playback response, not the monitor response, or not while you're monitoring the recording. It's inaccurate. It gives false highs. Okay, so this is all good. That's expected. This is a Type 1 tape, and I've got decent extended response out to 25 kilohertz. So that makes me confident that the heads are in good shape. Okay, let's get this transport out and lay it out on the bench in about 1.5 million pieces. Couple of connectors, 6 screws. This one only had 4, but it will have 6 when it goes back together. On these decks, I actually isolate that transport from the chassis. I don't always show that, but it is visible in some of the videos, but I don't generally show doing it. Should unplug things before I move them. One of my interconnects are always falling apart. Yeah, I just want to get a quick read on these motor coils. Get that so you can see it. Okay, there you go. Just, zero out my leads first. Okay, 14.0 horseshoes on that one. And I cut through the oxidation. 14.0, that's good. Again, let's see, was it this one I couldn't get? No, I think it was this one. Okay, 14. Okay, that's really good. Satisfied with that. This looks to be an original board. Doesn't look to be one of the JPO Solar replacement boards. Get that wire tie clipped off. You can see how loose this is. Every one I've ever seen is just like that. If you see me put them back in, you'll see that I put a little drop of blue Loctite on the threads when I reinstall them, so that won't happen again. Now I have one of Jefferson's replacement boards here. I keep these in stock in case I ever need them, but I've always successfully been able to repair the original ones. So you can see that they look a little bit different. So far I've yet to ever have to use one of these replacement boards, but you know, they look to be high quality, and I'm really happy they're available. And one thing I have noticed is that on these replacement boards, he puts polarized caps on C12 and C14, whereas the factory uses bipolars. I don't know the reasoning for that, but I put bipolars. And if I ever did use this board, I would recap it with conventional electrolytics, as I will this board. All right, let's get this thing apart. I plan to skip around on this quite a bit because I've done these a few times already in great detail, and so I think I'll just touch on, you know, different aspects of it maybe that I haven't shown in other videos. Maybe I'll throw a card up here to one of the other videos of the full overhaul. So a couple of springs and a couple of screws, and that well will come right off. And one of the first things I plan to check here while I'm doing this is the head height, and see where that sits also now. Now first look at the heads. Sorry for the focus. And there's that nut that's always loose. Most of the time I can just twist that off by hand. This one's pretty sticky. I didn't see it right off, but there is some there's an attempt at some kind of thread lock on there. It's some kind of black goop that, you know, this should just come off easily. This should fly off of there, but I'm having to get a little bit more torque on it because of that black goop they put on. That didn't work, obviously. Now we'll get that cleaned off of there. Amazing. They didn't even put it on the part of the thread that was needed it. It might have held if they'd have got it on where it looked like they put it on afterwards, actually. See that? It didn't even get down where it needed to be. It was an afterthought. I don't even know what it is, but it didn't work. Okay, we'll get back to that in a minute. Free up the rest of the wires. Now the brakes are another good indicator of the wear, and these look brand new. Look at all the grease in this thing. They have just blathered it all over. Why? Why so messy? This is not good. Just quickly check the head height on this. Again, just more or less trying to deconstruct why the azimuth was so far off. Now, if I find that the height is a long ways off, or that the tilt is way off, then that tells me one story. If I find that they're pretty close, then that tells me a different story. Get all the way up there. Now the guides seem to be pretty close. I'm not seeing a whole lot of tilt here, but I'm also going to do it the way I normally do, which is to put a piece of paper behind and shine the light on the paper, and then get level with the gauge bar. And I'll show you a picture of that right here. So this is how far out of parallel the head is, the head tilt adjustment, and this is pretty common. I see it a lot. I'll get it closer to that when I put it back together, of course. Now this is going to be quite a cleanup job on this one. Yeah, get a few screws out. Take a look at this pinch roller. Now it's glazed over, but it looks salvageable. Probably do a precision grind on that. Again, just the sheer amount of grease, and where it is, it's in places that don't even require, why do we need grease there? Amazing. Look at this. All that's doing is collecting debris. It's not lubricating anything. Try to get these brakes off without filling them full of grease. Yeah, they look pretty good. They've got a little bit of a, I don't know, a little bit of a film or coating or something on it. Kind of a, there's stuff all over this transport. As I work on it more, I just find, I don't know, coating of different things. Who knows? But it'll all get cleaned up. Let's see how much grease is underneath this. Yeah, they could have put more on there if they tried. That over so you can see it. Yeah, this is all going to get a wipe down, and it's going right in the ultrasonic cleaner. Wow, look at that. I wonder if they figured out that they had used grease in the past that that got hard and got sticky and gluey, and so they changed grease, and I don't know. Come on. There we go. We'll give all of these a cursory wipe off and then throw them in the ultrasonic. I like to keep things together in parts trays. I don't like to just make a circle of parts on my workbench. That would come back to bite me if I did things like that. I keep all of these parts separated in trays, or in some cases muffin racks, you know, whatever works. There's a little Teflon, or Delrin, probably. It's probably a Delrin thrust bushing in there. Those look good. No appreciable wear. A little bit lubricant there, not too much. Now I'm wiping this off and I'm seeing the grease has really stained the zinc plating on here. I assume it's zinc, but it has stained it, and it's looking like it's actually, I don't know, dissolved it a little bit, or anyway, it hasn't helped it. Let's have a look at our gear train here. This is the B gear. I'm curious to see if these have been replaced. Jefferson does offer and sells all of these gears. I generally don't replace them. I do, of course, the C gear up on top I do, but I prefer the laser sintered ones that I buy out of Germany for that. But the ones I've seen, and I have those here in stock also, they're high quality. They are injection molded, and they should be fine. But typically I don't see these failing. I just look them over and clean them and reuse them. Of course, replacing the C gear. The reason why that C gear fails is because it's typical in gear trains to make one gear out of a different material to quiet them down. And this is a noisy gear train. And so that's why they did that. Now this looks to be not the factory gear. This looks like it's the replacement gear. So that's fine. That's what I expect. It's been in his hands. This is the A gear. And that There's no way to tell exactly other than looking at the injection marks, but I assume that he probably replaced all of these. I'll sticky on that. He also sells this cam, if that's ever something that's needed. Didn't really need to take those out. Okay, fast forward through some of this now. Just removing screws, nobody needs to see that. Give these leaf switches a cleaning. Just take the covers off of those and run some paper between the contacts. Just mark these, I pull them off and resolder all of them. They use some very thin wires on these, and I just like to give them a fresh end. Everything looks good there. Even the idler tire doesn't look too bad. Now, before I close up for the night, I'm going to put a few drops of oil on these front sintered bearings and just let them sit overnight until I get back to it the next day. This is the little tool I made to remove this pivot assembly. This one's really stuck on here well. Imagine trying to do this with a couple of screwdrivers and how much damage might be caused. Just a little bit at a time, sneak up on it. Let's see if I can pull it off now. Yeah, not even close. There it is. This is what has to be done if that gear that just fell off ever needs to be replaced. And that's why I made this tool to begin with, and be able to service the motor without breaking the bracket. This little thrust spring here got a little bit deformed in the process, so I'll reshape that before I put it back on. And I use this Nye oil on the motor bearings. I'll put a pretty good amount on, and just like I said, let these sit overnight, and I come back the next day and that will be completely absorbed into that bearing. So like 2-3 drops a piece. I don't believe these motors have any sort of excess wear on them, so there's no reason to take them apart and lubricate the back bearing. If I can avoid disassembling these, I will. It's the front that takes most of the radial force. The back one is almost a guide, but they do dry up. Sometimes on some of the motors it's possible to lubricate that back one and without disassembly. So just looking at them by eye. Slight amount of wear on the record head. Repro head looks good. We'll get these under the microscope and make a determination on what to do from that point. But all the indicators are that they're both good. Physically they look good, and they also did the job on the recording and playback. So we'll take them off here. Now what I do, since I have set the height on these, or at least checked it, I've got a gauge block stack, which is going to be 208.5. That's 0. So 209 thousandths. And that is what fits between the heads and the bracket. And that'll just barely slide in here. And so when I go to put these heads back in, this will be my reference, and it gets me very close to where I need to be, so I don't have to spend so much time setting all the different axes and the azimuth on this. It just gets me close. It's a time saver. When I replace these springs, I've showed this in other videos also, I dampen these springs, and also the posts. Not too bad on this one. They're short posts, but I still like to do a little bit of vibration dampening on all these parts. I don't know how much of that will show. I've shown it in the past. Again, separate part strays for everything, not just loosely rolling around the bench. And there's the erase head shim. I don't think that's ever been off. Let's take a look and see what this thing makes. So that's an 8/1000 shim. These erase heads also need to be checked because they are plastic housings and they will warp and shrink with time. And I've seen these to the point where they've moved around so much I had to physically sand them back into alignment and then shim them. And so they need to be checked as well. It's not as critical, but every little bit helps. This is the kind of the process of removing as many variables as possible on these mechanics. We call this blueprinting. I'm sure people know that everything manufactured is manufactured with tolerances. Otherwise, it would be unaffordable. And each of these parts, all they have to do is hit the range inside that tolerance. And once it's there, they put it in the bin and go on to the next part. The idea behind what I call blueprinting, or what we used to call blueprinting, is to reduce all those tolerances, tighten them up so that everything operates at a more precise level. So individually, these little things really don't change much, but the cumulative effect of having everything in a tight spec makes the machine operate with greater precision and just better performance all the way around. And that's what I do on these decks, is just tighten up the operational tolerances. And the results speak for themselves, really, in the tests. So they've had a bath in the ultrasonic. We'll just give them a wipe down with a Kim wipe. Paper towels shed. Kim wipes don't. And I don't want anything interfering here. Come on out of there. There we are. Now what I'm using here is a non-corrosive ultrasonic cleaner, and when mixed with distilled water at about 20:1, it won't cause any corrosion on steel parts. This is really great stuff. So this is following cleaning, and you can see how badly that grease stained this coating. Pretty interesting, actually. This is 100% clean, and that's what it looks like. So I don't like this grease at all that they used. How is it that I've taken apart machines 40 years plus old that have grease in them, and none of this happened? And this one's a fairly new one. I think this was around, I think it was 2014 I saw in one of the motors. 2004, I can't remember, but this is a much, yeah, it would have been 2004, I suppose. But anyway, it's a much more current deck. And here's some more of that just film that's on things. And again, this is after cleaning, and I scrubbed this part with a nylon brush, and this little red coating here didn't come off. So what all this stuff is, I have no idea. It may have been just a protective coating that they may have used for whatever reason, but you can see it flaking off there. But you know, I don't want any of this stuff coming off and binding up. Okay, clean. Off to the motor. Now, of course, this will get a full recap. Change these SMDs out to conventional electrolytics. I'm just using the 2 soldering iron method this time. I do it different ways, just depending on, I don't know, I guess different ways for the videos, probably. Scrub the old solder off the pads and use a little flux on these. I'll throw a card up here to one of the videos where I've done a complete step-by-step overhaul on these, and you can take a look at that if you want to see more detail. But like I say, I'm going to just kind of fast forward through a lot of this because I've done them before in the past, and unless something is different or something is unusual, now have a look at the grime on this capstan shaft. So I don't want to pull that shaft through those bronze bearings with all that debris on it. I'm going to clean that off before I pull it through, and it's not wanting to come off. But look at all this. This is, look at that. And I haven't even made a dent in it yet. There's a lot more to go. Yeah, I think I'll just turn the camera off here and clean that up the way I want it. Okay, there it is. That took about 5 minutes to get all that debris off. Okay, windings look good. There's a lot of stuff going on in there too. But now I can slide this out without worrying about getting anything inside of those bearings. Yeah, they've done quite a bit of balancing on this one. I think we'll check this and make sure this is okay. Looks good, nothing's cracked, nothing's worn. A lot of times little bits of the magnet will be floating around in there. You know, obviously everything was working, so I don't expect to find much. I'll finish cleaning these threads off. Very nice. Now I started looking at this potting compound around these coils, and all this is flaking off also. And I don't want it. I don't want this flaking off and getting inside of that bearing, that thrust bearing. You know, again, all of these motors have this, but this is the one that it's flaking off on. Okay, I'll finish this off camera. It's going to take a little while. And here it is, completed with the pads cleaned, tinned, the whole board cleaned off. And then all that cleaned off, and the Hall sensors repotted. And that's what it used to look like. So I feel good about this. Now I've been soaking the gear train just in the solution, in that same solution. It's a great cleaner, but I didn't put these in the ultrasonic. Just soaking in here for a little while. We'll clean these up. Okay, now the parts are all cleaned. And this is probably a good place for me to end this video. And then on the next one, we'll have a close look at the heads under some magnification, make a determination on what to do with these. I'll be contacting the owner and making my recommendations. And we'll be looking at the balance on the capstan. And I'll throw a card up here to another video, or maybe the making of the video of this balancing stand. And spoiler alert, the balance on this capstan is excellent. So that's it. Thank you for joining me, and I hope to see you again.